everyone, and welcome to Chapter 4, Section 3 on the addition rule. The key concept in this section is that we're going to present the addition rule as a device for finding probabilities that can be expressed as the probability of A or B, which is the probability that either event A occurs or event B occurs, or they both occur, as the outcome of a procedure. The key word for the addition rule is OR, which may seem a little counterintuitive, but please do note that the key word in any of these problems for the addition rule is OR. And it is the inclusive OR, which means either one or the other or both. So let's talk about what a compound event is. A compound event is any event combining two or more simple events. And the notation here would be the probability of A or B, which means the probability that in a single trial, event A occurs, or event B occurs, or that they both occur. The general rule for a compound event is when finding the probability that event A occurs or event B occurs, you're going to find the total number of ways A can occur and the number of ways B can occur, but you need to find that total in such a way that no outcome is counted more than once. So for a compound event, here's the formal addition rule. We're going to have our probability of A or B equaling the individual probability of A plus the individual probability of B minus the joint probability of A and B. Okay, we also have so this was our formal addition rule. We also have what we call the intuitive addition rule, which is essentially just using words to describe what we just saw. And it tells us that to find the probability of A or B, we're going to find the sum of the number of ways A can occur and the sum of the number of ways B can occur, and we're going to add them together in such a way that every outcome is only counted one time. So the probability of A or B is equal to that sum divided by the total number of outcomes in the sample space. All right. We also need to discuss here what we call disjoint or mutually exclusive events. Events A and B are considered to be disjointed or mutually exclusive, those two words mean the same thing, if they cannot occur at the same time. That is, disjointed or mutually exclusive events do not overlap. So let's look at these two Venn diagrams. Here we have two events that do have overlap. We have our probability of A, our probability of B, and this orange section where they overlap would be our probability of A and B. So when we add them together, we'd have to be careful not to double count this area. Whereas in this diagram here, we have two disjointed or mutually exclusive events. You have your probability of A, your probability of B, and there's no overlap between them. So based on that, complementary events, which we discussed in the last section, meaning A and everything that is not A, must by definition be disjointed because it's impossible for an event, such as event A, and its complement, not A, to occur at the same time. So a couple of things about the rule of complementary events, and I'm not sure how this is going to show in the PowerPoint because my computer seems to be jumbling it, but let me just walk you through this, and if it is confusing, I apologize for that. Here, we know by definition that if we add the probability of A to the probability of not A, it must equal 1, because altogether the two must be 100% of the different possibilities, or 1 in terms of the probabilities. We can also, if we don't have the probability of not A, we can subtract from 1 the probability of A to solve for the probability of not A. And vice versa, if we were missing the probability of A, but we had the probability of not A, we could subtract that from 1 to solve for the probability of A. So it's important here that you're comfortable being able to rearrange the equations so that you're able to solve for variables that are missing within your problems that you're working on. And then here is a Venn diagram just kind of showing this, again, that the probability of A and the probability of not A together equal 1. So if you were solving for the probability of not A, but you had the probability of A, you could subtract it from 1 to solve for what you're missing. Okay, that ends section 4.3 on the addition rule. Up next, section 4.4 on the